Hi everyone. I'd like to read to you our story, The Circulatory Story. Please follow along as I read, and the author is Mary K. Corcoran, illustrated by Jeff Zinkis. Yesterday, we went on a scavenger hunt of all the different text features. Please notice those as I read. Also, think about what the main idea will be. In other words, what does the author want us to know? What is it mostly about? Sorry, Rosie's barking in the background. Can you feel your heart beating? Ever wonder what's going on inside the veins of your arms and legs? And what's up with the bleeding when you get a scrape? You don't have to yell, oops, sorry. It's time to find It's time to find out how your heart, blood, and blood vessels work together as you take the best ride of your life. It's a trip through the body's circulatory system. Your adventure begins in a tiny drop of blood. Have a nice trip. See you next fall. Get it? See you next fall. So, there is a green character who is taking us on the journey. Saddle up that cell. See the red thing that looks like an inner tube without the hole? It's an erythrocyte, and it's one of the three cellular components or formed elements of blood. We'll meet the other components later. An erythrocyte is also known as a red blood cell, and This red blood cell is just one of millions found in a drop of blood. These cells carry oxygen. No, they don't carry it in a suitcase or a backpack. Instead, the oxygen attaches to a chemical called hemoglobin that's found in red blood cells. With hemoglobin's help, blood can transport oxygen to all parts of the body, including cells and tissues, which need a constant supply of oxygen in order to work. Nice job, Red. Go with the flow. Busy red blood cells are always on the move, but how do they flow from one part of the body to another? The blood they travel in is full of substance called plasma. Plasma contains some dissolved proteins, but it's mostly water, about 90%, which lets blood flow pretty well. Without plasma, these cells would cause a traffic jam. Blood vessel, platelet, whee! Red blood cells, white blood cells, oxygen, yeehaw, plasma. Your heart open 24/7. Traveling on your red blood cell, the first place you'll visit is the heart. Your hard-working heart is about the size of your fist. It's located in the chest, a little toward your left side. It's enclosed in a special protective sac called the pericardium. The heart is strong and muscular and works day and night. In fact, it started beating 8 months before you were born. By the time you're 70 years old, it will have beaten about 2.5 billion times. Meanwhile, in the year 2072, congratulations, your heart has beaten 2.5 billion times. Gee willikers. Stay on your own side. You'll notice that the heart has two sides, the right side and the left side. A thick wall called the septum separates the two sides. Each side has its own job to do. The left side receives blood from the lungs and pumps it to the whole body, while the right side receives blood from the body and pumps it to the lungs. You might think of the heart as a divided highway. A divider separates the lanes. and cars must stay in their own lane. If not, there's trouble. My left is your right. To the body, to the lungs, from body, from lungs, from body, to body. Next, exit the body. Rooms with a view. The heart not only has two sides, it also has an upstairs and a downstairs. Each side has an upstairs room and a downstairs room, and each side's upstairs and downstairs are connected. The upstairs rooms are called atria, atrium in the singular, and the downstairs rooms are called ventricles. So in total, your heart has 4 rooms called chambers. Unlike the rooms in your home, these rooms have no furniture. They're empty, leaving plenty of room for blood to flow through on a constant basis. Tricuspid valve, pulmonary valve, and mitral valve, aortic valve. I wish my room looked that clean. Beat it. It's like Grand Central Station here in the heart, with blood flowing in and flowing out with each beat. Each time the heart beats, it squeezes and relaxes. This action sends blood through the heart and into the blood vessels that go to the different parts of the body. This left atrium is a nice place to visit, but don't get too comfortable here. You're moving down to the left ventricle. Hold on to your cell. You're going to the left ventricle the hard way through a hole in the floor. Atria squeeze, ventricles squeeze. Holy moly! Shut the door. If you look up, you'll see that you just went through the mitral valve. That thump was the sound of the valve closing. Heart valves are one-way doors that keep blood flowing in the correct direction. When the left atrium contracts or squeezes, the mitral valve opens. This lets blood go through the left ventricle. Then the valve closes, and the ventricle contracts, pushing the blood out to the rest of the body. There are thin, strong cords that connect the valve to the ventricle wall and help keep the valve shut. Like most pumps, the heart can function with slightly leaky valves. With more serious valve problems, the valve doesn't close or stay closed properly. This lets blood flow back from the ventricle to the atrium. This makes the heart have to work harder, which could damage it. But when everything works well, blood goes through the valve and keeps going where it's supposed to go. Everything looks good in here. Pumped up. The left ventricle is a megamuscular chamber. Its walls are thick and strong. They have to be because they pump blood out of the heart and send it to the rest of the body. That's where you're headed to, around the world. Blood doesn't just slosh around in your body after it leaves the heart. First, it goes through another valve, the aortic valve. Then it travels through the blood vessels, which are like the tunnels of a super subway system. The main goal of blood vessels is to nourish body cells by bringing them things that they need, like oxygen. Blood travels through the entire body in different types of blood vessels. The main kinds of blood vessels are arteries, capillaries, and veins. Arteries carry blood from the heart. Veins carry blood to the heart. Capillaries connect arteries and veins. So here we have the vein, capillary, and artery. If all the blood vessels in the human body were lined up to end, you'd have to travel about 60,000 miles to get from one end to the other. That's equivalent to going around the world twice. Come on, one more lap. The arching aorta. Arteries are big. All arteries have thick, elastic walls. These walls have 3 layers, each with lots of give so they can expand as blood passes through them. The artery you're traveling in as you leave the left ventricle is called the aorta. It's the biggest artery in the whole body. It's an important one too because all blood travels through it before heading off to the other place, to the body. Oop, didn't finish that page. So here's the pulmonary artery, the aorta. There's to the neck and the arm. As you travel through the aorta, you'll notice that it forms an arch. Like subway tunnels, 3 blood vessels branch off the top of the arch. These 3 blood vessels are arteries that carry blood to the head, neck, and arms. The aorta continues on, however, carrying blood downward. The blood travels through the aorta, will eventually branch off to reach the rest of the body, including the lungs, kidneys, stomach, intestines, and legs. So here we have the externa protective, the media elastic, intima smooth. Header, don't pressure me. Due to the pumping of the heart, blood moves through the aorta under a lot of pressure. The measurement of pressure on the walls of arteries is called blood pressure. This pressure moves blood to the smaller blood vessels. There's one now, it's a capillary. This is going to be a tight squeeze. There's a lot of traffic today. Tiny but terrific. Capillaries are so narrow that red blood cells pass through them one at a time. Some capillaries have more space than others, depending on where they are in the body. For example, capillaries in parts of the intestine and in the brain are narrower or smaller in diameter than those in the skin. Capillary walls are only 1 thin cell layer thick, but that's a good thing because, whoa, what was that? 1 at a time, please. The pressure is on. Header, excuse you. PU, your red blood cell just passed gas. Well, actually, it released the oxygen it was carrying. And the type of gas doesn't really smell. The oxygen passed through the capillary wall. Good thing these walls are so thin, and was picked up by a body cell. Then the body cell released carbon dioxide, which passed through the capillary wall and was picked up by the red blood cells. Don't leave yet. There's more to come. Not only has oxygen arrived at the lucky little body cell, but nutrients have too. When oxygen from the red blood cells and glucose, a kind of sugar absorbed by the bloodstream from the digestive tract, meet in a body cell, they react to produce energy, carbon dioxide and water. Water is always present in the body and it's constantly being reused. This super reaction is called cellular respiration. It's important because it gives you energy to stand, energy to exercise, and even energy to circulate blood. So that little body cell now has everything it needs. Plus, we pick up its waste, carbon dioxide. Special delivery. Why, thank you, body cell. Will you take this? But of course, carbon dioxide. Nowhere to go but up. The red blood cell you're on and the others around you have done their job. They've carried oxygen to the blood cells. Now it's time to travel into a vein and head back toward the heart. Veins are blood vessels that are thinner than arteries, but thicker than capillaries. But thud, what did you just bump into? It was a valve. You better watch which way you're going. Like the heart, many veins have a cool way of preventing blood from flowing back the wrong way. One way, venous vein valves. These valves not only keep blood from going backward, they also help blood climb up to the heart as it travels against gravity. Just then, outside the body, whee! Uh-oh. Sorry. Rocks don't talk. Ouch! My knee! Het or human, we have a problem. Here you are in the right leg, ready to return to the heart, but look out. There's an army of leukocytes, aka white blood cells, headed your way. What on earth is going on? The white blood cells are responding to a cut on the leg. Better stand back. These white blood cells are going to engulf the invading bacteria that have made their way into the body through the skin. The rod-shaped bacteria could cause an infection in the body. Go Army. White blood cells are one of the three components of blood. Like red blood cells, they usually travel through the bloodstream. Unlike red blood cells, troops of white blood cells can move through the tissue into parts of the body. Don't look for these cells to be dressed in camouflage, though. Not all these soldiers look alike. Some, like macrophages and B cells, look different from each other and do different jobs. Like an army, macrophages increase in numbers surrounding the invaders and destroy the bad guys. Keep up the good work, Mac. B lymphocytes, or B cells, another kind of white blood cells. They make antibodies, chemicals that help protect you against certain diseases. Antibodies also give you immunity from the disease, meaning they help prevent you from getting it again. That's pus, Gus. If not cared for properly, some cuts may get infected. A yellowish fluid called pus can indicate infection. A cut with pus needs proper medical help. To help prevent infections, wash the cut with soap and water and cover it with a bandage. Clot a lot. What a battle. As all the action is happening, more troops, platelets, the last of the three components of blood, arrive on the scene. These little guys, with the help of special fibers called fibrin, help to form a clot that stops the blood from flowing out of the wound. Soon the clot becomes a scab, which gives the damaged skin time to heal. Don't pick at it. They're as good as new. Thanks. Under the bandage. So we have platelets, fibrin, and white blood cells. Inferior or superior? You've come a long way from the little cell that passed gas. In fact, you're in a vein called the inferior vein, vena cava, and you're almost back to the heart. You have completed a trip one part of the circuit of the body's circulatory system, the system circuit. This circuit nourishes most of the body with blood. Now there's nothing inferior about the inferior vena cava. It just means that blood going through it has been in the lower part of the body. If you had been in the upper body, you would have gone through the superior vena cava. The blood in both of these veins is oxygen, poor or deoxygenated, because a lot of the oxygen from the red blood cells was given to the blood cells. Almost there, right atrium of the heart. So system circulation, wow. Blood supplies to the lung, red arteries, heart, blue veins. Deja vu. The interior vena cava brings you into the heart at the right atrium. Then it's down through the tricuspid valve, which works just like the mitral valve, but it's located between the right atrium and the right ventricle. It feels like we've done something like this before. The tricuspid valve, the pulmonary valve, How shocking! Before you leave for the right ventricle, there is something in the right atrium that you might like to check out. The sinoatrial node. This most amazing little group of cells is known as the heart's natural pacemaker. It sends electrical signals to the atria and ventricles, telling them to beat at a certain pace or rate. So when a person is exercising, the heart's chambers will contract more quickly, sending more blood and therefore more oxygen to the body cells that when a person is at rest and doesn't need as much oxygen. Did you get a charge out of that? I sing the body electric. Time to fill her up. Next part of the circulatory system, the pulmonary circuit, is shorter but no less important. Pulmonary refers to lungs, and that's where you're headed. After saying goodbye to the right ventricle, say hello to the pulmonary valve and the pulmonary artery. This is the artery that will bring you into the lungs. Take a deep breath. You're here for oxygen. A hearty review. Have you ever traded part of your lunch for a part of your friend's lunch? Well, it's the same in your lungs. Carbon dioxide is breathed out when you exhale, and oxygen is taken into the body from the air when you inhale. Sounds like a good trade. Now, do you remember when the red blood cells released oxygen to the body cells? They got that oxygen here in the lungs. Do you also remember that the body cells pass their carbon dioxide to the red blood cells? Now it's time for the red blood cells to get rid of the waste gas at the lungs. This gas exchange takes place in the lungs' alveoli, or air sacs. Capillaries surround the alveoli, as you saw earlier. Capillaries are so thin that the gases are easily exchanged here. Isn't that interesting? Heartward bound. After this great gas exchange, the body goes back into the heart. The body is called oxygenated blood because of all the oxygen it is carrying. Can you guess which side the blood goes into? Yes, it goes into the heart's left side. And blood will now be pumped out the left ventricle and on to the body cell. Heart to heart. The last part of the circulatory system is the coronary circuit. It's the shortest circuit in the body, but it's important because it supplies the heart itself with blood. As blood leaves the left ventricle through the aorta, blood vessels called coronary arteries branch off of the base of the aorta and bring blood to the heart cells. Without this supply, the heart cells couldn't survive. Coronary veins carry blood away from the heart. For all your hard work. Oh, shucks. Fighting plaque. Oh no, look at the sticky gunk on the walls of this coronary artery. It's plaque. No, not the kind that can build up on your teeth. The plaque in arteries is a fatty substance. An unhealthy diet, especially lots of fatty foods, can cause plaque to build up in people's arteries, which can lead to a clog in a coronary artery. Think of the pipes below your kitchen sink. If it's too much gunk built up, water can't pass through the pipes. Then it's time to get the plunger. Adults with lots of plaque in their coronary arteries are at risk of having a heart attack. Some of the nasty plaque may prevent blood from reaching the heart cells. Without oxygen, these cells become damaged. When this happens, a doctor has to unclog that artery. Treating your heart well helps you prevent heart trouble. 2 heart smart ideas are to eat right and exercise. This way, the heart can be buff and healthy. This advice is straight from the heart. Get it? Straight from the heart. The circulatory story. You visited 3 kinds of blood vessels, hungry body cells, and the 4 chambers of the heart. Plus, you've seen breathtaking views of the lungs. If you'd like to go again, you'll have to have plenty of chances to catch a ride because the heart beats about 100,000 times per day. Blood circulates through the blood over and over again each day of your life. Many things must happen in just the right order to ensure that everything in this incredible body system works properly. So, the next time you feel your heart beating or thinking about your veins or getting a scrape, remember your trip through the circulatory story. You must admit, it sure is great to be to circulate around and around thousands of times each day. Red blood cells must get really, really dizzy. Thump. Now, here is your glossary in the back of your book, which contains many of the words and terminology that we read and their definition. Books that are informative or give a lot of information or have challenging vocabulary often will include a glossary. Glossaries are included in the back of the book. They are not like dictionaries. Dictionaries will give you more information about each word. Glossaries are mainly giving you a meaning of the words that are in the story, but very similar to a dictionary. I thank you for reading along with me, and I hope you're having a great day.